Okay, so now I'm going to go over to Notepad and work out some of these examples for you. Let's start with the one we just had. So determine the number of protons, neutrons, and electrons in each of the following species. So the first thing we're going to do is determine the number of protons. And if you remember, the protons are always the one in the lower left-hand corner. So for chlorine 1735, the protons are 17. And then the electrons are 17, because it's a neutral atom. And then the number of neutrons is just equal to 35 minus 17. So 35 minus 17 would give you 18. So that's how many neutrons you have. Now in the next one, you have chlorine 17 again, because 17 is always chlorine. Otherwise you didn't have chlorine. The electrons are also the 17 as well. But now you have 37 as the atomic mass. 17. So now you have 37 minus 17, so the number of neutrons is equal to 20. Okay. Now the next one is potassium, but there's no number in the bottom, so now you have to go to your periodic table. So I'll pop over to there and bring up the periodic table, which I have over here. And there's something called p-table, and it's ptable.com, and it's nice because it's kind of dynamic. So you just look up potassium, and it'll pop up potassium over there in the corner a little bit bigger and give you all the information you need. Now you notice here it's on the bottom, so potassium 19 is the number of protons, and the atomic mass is 39. So we can just go back to here. So 19 is the number of protons, because that's always potassium. And then the atomic mass was 39 for the regular one, but now we have 41, so this is the number of neutrons is going to be 41 minus 19, so that's going to give you 22 as the number of neutrons in that particular isotope of potassium. And then again, the electrons are the same as the protons because this is neutral. And in carbon 14, in this time, carbon is always 6, so the number of protons is 6. And you could look that up on the periodic table. I'm not going to look that one up for you. The number of electrons is 6. And now the mass is 14, so they're saying the mass minus the number of protons gives you the number of neutrons. So in this case, the neutrons is equal to 14 minus 6. Minus 6. So that is equal to 8. And that is the number of neutrons. Okay, so let's go back to our slides. Oops. And now we can solve for each of these, giving the number of protons, neutrons, and electrons. Now, just as you notice when I went to the periodic table, sometimes they're written a little bit different. So the whole number is always the atomic number, and they're in order on the periodic table, so you can always figure out what it is. And then the bigger number is the atomic mass. And sometimes the bigger number is not always going to be equal to a whole number, and we're going to understand why in a minute. It has to do with the number of isotopes. But when you are solving for the number of neutrons, you're always going to look for the nearest whole number of neutrons. You're never going to have a partial number or a fraction or a decimal number of neutrons. So it's always going to be the nearest whole number. Okay. So we said that this is how we can determine the number of protons, neutrons for any element. And I just pointed out that sometimes the numbers aren't always even. And the reason for that is because there are isotopes. Some elements have 2 or more isotopes. So they have the same atomic number, but they have different masses because they have different numbers of neutrons. So hydrogen that we're used to has a 1 proton and an atomic mass of 1. But there's also something called deuterium. And deuterium has an extra neutron. So the mass is actually 2. And tritium has an extra neutron, so it has a mass of 3. And deuterium and tritium are still hydrogen because they only have 1 proton, but these extra neutrons make them heavier, and that's sometimes what you call heavy water. And there was, every once in a while you hear things about, benefits or not benefits of heavy water, and it's water. Don't pay attention to any of that. So there are a number of different elements. Most elements, I should say a lot of elements have these other isotopes. So hydrogen has 3, helium has 2 different isotopes as well. Lithium, you'll see, has 2 different isotopes. Boron will have 3. Carbon has the 3. Carbon 12, carbon 13, carbon 14. If you've heard of carbon 14 dating, we can understand how old things are based on how much carbon 14 is in them. And we'll get into that when we get into nuclear chemistry, which actually we don't do till next semester. But there are a number of different isotopes, especially as you get out to the bigger actinide lanthanide series like this one here, like uranium. So uranium has 92 protons because it's atomic number 92. Uranium-235 has 235 minus 92, so it has 143 neutrons. So when you get out further, they're not always equal to the number of protons. It starts getting to be different, and you start having more different options. Uranium-238 would have 146 neutrons with the same 92 protons. And these aren't as there's not as many of them. The relative percentage is much lower. So we can look at why these numbers have a decimal place associated with them is because it's a smaller percentage. So it's not just an average of the two different types of element with neutrons and protons. They're actually a weighted average. So for example, here we have boron 10. It has a mass of 10.01. It's 19%. It's found in 19% of the element that you find. Boron 11 is 80%, and that's most of what you would find. So it's not just a mass of adding 10 and 11 or adding 80 and 90, it's actually a weighted average. So you have to take each one and multiply it by its mass, and then add it to the other one and multiply by its mass. And now you get the average atomic mass, and now it's 10.81. So that's why it's not always 11 for B11 and 10 for B10, because it's a weighted average. And since it's 80% B11, you could see that the number is going to be a little bit closer to the amount of 11. So we can look at another problem like that. Oxygen is another element that has 3 different stable isotopes. Oxygen 8 always has 8 because that's the number in the periodic table, 8 protons. Oxygen 16 is 99% of the oxygen that we see in the atmosphere, or in your body, or whatever it is. Oxygen 17 is 0.038%, so it's very little of it is that. And then oxygen 18 is 0.205%. And they each have their respective weights of 15.9949, 16.9991, and 17.9992. And you can use these to find a weighted average to give you the average atomic mass of oxygen. I'm going to go back to my notepad and do that by hand again. And let me see if I can slide down a little bit. Go back to here. And we can do this next one. So now what we're going to do is take each one and multiply it by its weighted average. So the first one, the most stable one, is this one here. That's 99% of the oxygen that we see. And it has a mass of 15.99. So this is going to be 0.99757. So that's the percentage. So you move the decimal over twice, so it's 0.99 times 15.9949 plus, we'll go to another color pen for the next one. Now we have 017, which is only 0.038%. So you're going to have to move your decimal place over 2 more. So you're going to get 0.00038 times its atomic weight, molecular weight, is 16.9991. And then the last case, we'll do another color pen, go to blue. The last case has an atomic mass of 17.99, and that's 0.205%. So you're going to add to this plus again 00205 times 17.9992 equals. So you add these 3 weighted averages, and that will give you the weighted atomic average for oxygen. And if you look it up on the periodic table, that should be close. So I'm not going to do the multiplication for you, but you can plug that in and do that yourself. Okay. So the last, those are the 2 examples, and then we'll see what. The next thing we want to look at is ions. When the number of protons and electrons are not equal, then there's an electric charge, and it's called an ion. So the charge on the atom is the number of protons minus the number of electrons. All along we've been saying that we had a neutral atom. Well, in some cases you don't have a neutral atom. So if the atom gains an electron, It has a negative charge because it's gained this negative charged electron, and it's called an anion. So a neutral oxygen that gains an electron or 2 electrons now becomes an anion with a -2 charge. An atom that loses an electron, so it loses a negative thing, that means it's left with more positives than negatives, so now it's a positively charged ion, and it's called a cation. And you can do the same thing with looking at its symbolism. So helium, for example, would have the 2 in the bottom because that's always helium. The mass number is 4, and now you'll write the charge up here in the upper right-hand corner. So you see the 2+ charge. And the same thing for magnesium. Magnesium is always 12. The atomic mass is 24. A lot of times it has a 2+ charge, which is written up in the right-hand corner. And you can also go and look at calculating once again the numbers of electrons, protons, and neutrons in something that is charged. So in this case, we have a charged ion. Try another different color. So this is platinum. Platinum has a mass number of 195 and contains 74 electrons. How many protons, neutrons does it contain, and what is its charge? So normally you think electrons and protons are always the same, but not if it's charged. So we have to go and look up platinum on the periodic table again and find out what our number of protons is on the periodic table. I have that here. Go back to my periodic table. Whoops. Periodic table. So the periodic table was here, and platinum should be somewhere here in the middle. So there's platinum, and you can see a platinum is atomic number 78. So the 78 is what determines the number of protons in there. So platinum always has 78 protons. So we know that protons is equal to 78. And they said electrons was equal to 74. So we already know that we're going to have a charge on here because we're short some electrons. How many neutrons does it have? Well, neutrons is just the same as before, so it is 195 minus 78. So that doesn't change. But you can't assume it's the 74. You have to go always look at the periodic table for the number of protons. Now, what is the charge on here? The charge, because this protons are plus 78 and the electrons are minus 74, there's not enough to balance. You're left with a net plus 4. So this platinum ion has a plus 4 charge. Okay, so this is looking at the symbolisms for ions and for regular atoms, and being able to figure out how many, from the mass number, how many protons, electrons, and neutrons you have, and you should be able to do this.